First Tech Challenge challenges kids ages 12 to 18 to program, design, build, and compete with robots.
First Tech Challenge is one of 3 engaging FIRST programs.
Every year they release a new challenge.
Once you get the challenge, you figure out your game plan.
Teams use a reusable kit to program robots in a variety of coding languages.
Every year you also learn more and more about coding, so then your code's gonna get better and better.
Personally, I do not learn hearing about it, but hands-on is just go into it. Instead of saying, oh, I know how to build this robot, I can say, I built this robot.
In First Tech Challenge, students are developing a broad range of skills.
Manufacturing, hardware, troubleshooting, but there's also a lot of things that you learn that you wouldn't necessarily think about. People skills.
Problem-solving skills, helping one another, helping other teams.
The program draws so many students that come in who just want to do the marketing, who just want to do fundraising. And that's a great thing that the kids learn very early on.
The model of FIRST has provided incredible opportunities for the students to interact with professionals.
Whenever I asked my mentors a question, they always flipped the question around and asked, where would you find the answer to that question if I weren't here? They slowly built my confidence up so much more to a point where we weren't asking them questions, we were just going.
Each team has to compete at a local event, win awards at the local event, and then they're able to move on to the first championship.
You walk into the room and there's that smell. The smell of robots.
There's different languages, different culture. It's just the best thing ever.
There are scholarships for colleges, universities, as well as technical programs.
I think it's incredibly important for youth to see careers in science and engineering as a possibility for them.
First Tech Challenge is like an avenue for me to express my creativity with like-minded individuals that later become my friends through the program.
First in one word, wow.
Fun!
First is inspiration.
First is amazing.
First is hope.
Okay, good morning, everyone. All right, so I know that everyone is already excited about with this First Tech Challenge for the Philippine Exhibition Game. So, welcome to everyone. So, if you are watching right now and really interested for this First Tech Challenge FTC Philippines Exhibition Game, so please comment down your school name, where are you coming from, or where you are watching right now. Tell us your school, tell us where is your location so that we could know who among you are really interested for this First Tech Challenge here in the Philippines. And if you are really interested and excited about the program, please share this live so that we could share this good news to everybody, especially those kids, those parents, or those school who are really interested in the wonders of robotics program. Okay, so please share this live, share it to your friends, share it to your schoolmate, share it to your school admin, share it to your parents so that they will be aware that we are having this wonderful program for our youth here in the Philippines. Yesterday we just accomplished the pre-teachers training in preparation for the upcoming 25th Philippine Robotics Olympiad competition. And I believe this is just a right time to launch this First Tech Challenge training session with you guys so that you will be aware that we'll be having the FTC Philippine Exhibition Game during the 25th Philippine Robotics Olympiad competition coming up this June 22 to 25, 2026 at SM Mall of Asia. All right. So if you're watching right now, please share the live video. Share it to your friends, show it to your classmates, share it to your school admin, show it to your coaches, share it to your family so that they know that we have this wonderful program for robotics. Okay? And if you're watching right now, please tell us or use the comment section to share with us where you are watching right now. Whether you are in school, whether you are at home, at vacation, whether you are in beach right now, because you can use your mobile phones to watch. Please share the live video so that they will be aware and they will be informed that we have this wonderful program that we are preparing for our youth in the Philippines. Okay, sounds exciting. We just accomplished the first Lego League last February 14. But look at now, we are moving forward, okay, offering new platform, new program that we could actually explore. Because I believe that this kind of platform are really helpful and able for us to prepare our youngster for their future career. Okay? All right, so we have our viewers, okay, from USA. Okay, shout out to Miss Maylene. Hello, Sir Gorio. Okay, from US. Thank you so much for watching live today. Okay, so again, share this video so that our youngster here in the Philippines will be aware that we are preparing something wonderful for everyone. Okay? So there are so many activities that we're actually preparing for our youngster here in the Philippines because we at Felta Multimedia, we really wanted to use our platform to prepare our youngster, to prepare our learners for their future career through the wonders of robotics innovation, of course. And if you are believing to that goal, to that vision, please give us some heart emoji. Okay. Yeah, we decided to launch this kick-off training session live so that if you are quite occupied at the moment, if you have some errands to do because it's weekends, yeah, we prepare to make it a live session so that later on when it's your free time, you can rewatch or you can review. Okay, but in case that there are questions that you wanted to clarify or is there any help that you wanted to ask from the team, please feel free to write it down on our comment section and our technical people will be very happy to assist you. And if you think that you wanted to embrace this new innovation that we wanted to offer to the Philippines, please feel free to send us a direct message on our social media platform and our team will definitely be there to help you and to support you. All right. So just use the comment section if there's question, if there are clarification, or if there are shout out that you wanted to do so, please use our comment section. Okay. So again, of course, good day to everyone and welcome to our online live session for this first tech challenge. Okay, it's a preparation for the FTC Philippines exhibition game. Okay, because we are starting. We are starting and we really wanted to help you guys clearly understand of what is the program about. Okay, so welcome to the official kickoff of this training session for the First Tech Challenge Philippines exhibition game. So if you wanted to be part of this exhibition game, please use the comment section and send us a direct message. So, today's marks the exciting start of another season where where our coaches, where our mentors, and our school, of course, be coming together to celebrate innovation, to celebrate teamwork, to celebrate creativity, and of course, robotics. Okay, I knew that everyone is preparing for the upcoming 25th Philippine Robotics Olympiad competition happening this June 22, 23, 24, and 25. All right. So, on behalf of Felta Multimedia Inc., and the First Tech Challenge Philippines community. Thank you for joining us virtually today and for being part of this growing movement that continues to inspire young innovators and our future leaders. So, the kickoff training session is designed to guide all the interested participating teams as we prepare for the upcoming exhibition game that's gonna happen on the 25th Philippine Robotics Olympiad. Okay? So, throughout today's program, you will definitely gain a better understanding of the game flow, game mechanics, game expectation, and game rules, and preparations needed for the season ahead. Okay, we just wanted to have this exhibition game so that we will be aware of what's gonna happen for this new platform. Okay, so more than learning about the competition itself, of course, this is also an opportunity for us to connect, for us to collaborate, and for us to grow together as one FTC community, as one Philippine robotics community. So, whether you are joining for the very first time, okay, whether you are returning for an exciting season, we are truly excited to begin this journey with all of you, of course. So, even though we are just meeting online, we encourage everyone to please stay active throughout the session. As I've mentioned, you can always use the comment section. You could always send us a DM. So I'm encouraging everyone to please participate. You ask question in the comment section and engage with your fellow teams and mentors. So there's so many questions, okay, coming in. Please, we're encouraging everyone. So get ready to learn, get ready to collaborate, and enjoy today's live kick-off session. And once again, welcome everyone to FTC Philippines exhibition game kick-off training session. Okay, for this kick-off training session po, we prepared, I think, 3 Saturdays session na ibibigay namin sa inyo, of course, for free to give you guidance. But later on, after this online session, of course, for those who will registered and for those who will embrace the challenge, we'll be providing a face-to-face training for in robotics training, it really requires that it should be conducted face to face. Okay, but for now, online will do. Okay, so moving forward, for many years, I know and you knew that Felta Multimedia Incorporated, our company, has remained committed to empowering schools, empowering educators, empowering students through innovative and transformative educational programs. So when we decided to offer robotics education in the Philippines, we also created such wonderful platforms where you could always exercise all the learning and all the skills. So, as the proud national organizer of the first Lego League Philippines and the Philippine Robotics Olympiad competition, Pelta Multimedia Incorporated has continuously worked to provide to our young learners with the opportunity to develop critical thinking, collaboration, creativity, and problem solving skills through robotics and, of course, STEM education. So, over the years, we have witnessed student growth not only as competitors, but also as future innovators, as future leaders, and change makers. Imagine 25th for the Philippine Robotics Olympiad. Those who join as volunteers before, those who join as competitor before, those who join as participants are now joining as a volunteer judges, as volunteer referee, as a volunteer marshal. And our community is really evolving and really growing. All right. So today, as national organizer, we are very proud to take another meaningful step forward as we wanted to continue expanding our vision for robotics education here in the Philippines. So, Felta Multimedia is now strengthening its commitment to the first community by advancing into the world of First Tech Challenge. Okay, so this initiative is really reflects our continuing mission to modernize education by creating more opportunities for students to experience higher levels of engineering, higher levels of programming, higher levels of innovation, and real world problem solving. So we believe that through First Tech Exhibition Game, we aim to help schools, to help our students explore more advanced robotics experiences while continuing to foster collaboration, to foster leadership, and of course, discovery. So, as we officially begin this FTC journey together as community, we thank all our partner schools, of course, our mentors, our parents, and students for your trust and support. So, we are very excited for what lies ahead, and we really wanted to look forward growing the first tech challenge community together here in the Philippines. Oh, look at the comment section while we are sharing this good news. Please share it to the community so that they are aware that there are new coming things prepare for our youth here in the Philippines. So look at the comment section. There are questions like, will this replace after this coming season? Of course not. We are just evolving, and we just wanted to offer advanced robotics for our youth here in the Philippines. So it's not. Okay. And we have some greetings from our friends. So hello RD Balante from Mines Elementary School. Oh, we have some testimony here on our comment section from US of A. I started with Felta. Now I'm here in the US teaching robotics. Proud Philippine Robotics Olympiad, WRO, and FLL coach. Wow! That's wonderful. Kudos to you, Sir Gorio ng Banlat. And keep safe and keep sharing the wonders of Filipino people to the US community. Okay. Ayan. Okay. So how about our other friends? Please share where you are watching right now so that we could do some shout out. So sa ating pong mga coaches na nandyan na po sa USA, sharing the wonders of our Filipino teachers. Ayan, mabuhay po kayong lahat at mag-ingat po kayo. And please, we are very proud from the bottom of our hearts. Okay, wow, nakakatuwa naman yung ating mga testimony on our comment section. So if you have wonders to share, to inspire our learners, to inspire our youth, to inspire our coaches, please use our comment section. Marami tayong mga friends na nandyan sa ibang bansa. Okay. And this Philippine robotics community is very proud of you. Okay? So, moving forward, ayan, hindi po natin kakalimutan si First Lego League. We just accomplished the 14th First Lego League last February 14. As we embrace First Tech Challenge, we wanted to evolve. Okay, please take note of that. We wanted to evolve for the community. So it will be another program, another platform for our youngster here in the Philippines. So, for talking about First Tech Challenge, for those who are new to the program, First Tech Challenge or FTC is an international robotics program that, of course, challenges our student to design, to build, to program, and to operate robots to compete in a dynamic and exciting game-based competition. Okay, so in FTC, students work in teams to apply engineering principles, to apply coding skills, to apply creativity, to apply strategic thinking, and to apply collaboration in solving real world inspired challenges. So more than building robots, First Tech Challenge encourages students to develop important 21st century skills such as leadership, communication skills, teamwork, and innovation and problem solving. All right. So stay tuned for later on. We'll be discussing thoroughly the game guidelines and the game rules and regulation and how you're gonna start joining the program. So each season, same goes with FLL, it introduces new challenge where team must think critically. They must adopt, they must continuously improve their robot design and their strategies, of course. So through the learning experience that they can get from the program, students are really exposed to hands-on STEM learning that prepare them for their future careers in science, technology, engineering, and beyond. Okay? So, as we begin this exhibition game journey together, we hope that this program will inspire more students, inspire more school across the Philippines to explore the exciting world of robotics and innovation. So keep talking, keep using the comment section. Ayan. So I guess we have some greetings. Good morning po. Is the FTC exhibition game a competition or a participation activity? It's gonna happen on the 25th Philippine Robotics Olympiad, and right now it's an exhibition game because we just wanted to showcase the FTC or the First Tech Challenge is really a thing that we are preparing for the future. Okay, so as I mentioned, as part of the exciting initiative of Felta Multimedia Inc., the FTC Philippines exhibition game will be integrated into the Philippine Robotics Olympiad this year because we just wanted to kick off and we wanted to share it to the community. One of the country's established robotics competition that continues to showcase innovation, talent, and excellence in STEM robotics education. So the exhibition games will be inserted on the 25th Philippine Robotics Olympiad competition. Okay? So magaganap po yan on the fourth day. Okay? Purely exhibition game where we just wanted to share with you the wonders of this First Tech Challenge. So we are also excited to invite everyone to witness the upcoming FTC exhibition game happening on June 25th during the Philippine Robotics Olympiad event. And this exhibition game will definitely serve as an opportunity for participants, for educators, and aspiring teams to see FTC robots in action, experience the game environment firsthand, and learn more about the competition format. Okay, so you are all invited to participate as an exhibition teams or participate as observers. Okay, So technically, when you do so, you will learn more about the competition format firsthand. Okay, and we wanted to have this on the 25th Philippine Robotics Olympiad so that school could discover participant could discover on how to become part of the growing FTC community here in the Philippines because we are just starting up because we wanted to level up and we wanted to evolve for you, for all of us. Okay. So, for those who are interested in joining us and exploring the future of robotics education through First Tech Challenge, we encourage you to be part of this exciting event on on the 25th of June. So, we're looking forward to seeing you there as we continue building and growing the FTC community together. Now, to help teams begin their FTC journey, we are also introducing the FTC starter code for this season team, the code. Okay, but thoroughly, we're gonna discuss that later on. So it's bigger bots, but technically to start up, there are starter bot as well. Okay, very challenging, but it's worth it. Yes, definitely po. It's true. So, to help team begins in the FTC journey, because we're talking about bigger bot now, okay, we will be introducing FTC starter bot as well. And every year there are season team, okay? But later on we'll discuss that thoroughly. The starter bot that we're gonna use, we're gonna showcase that later. So there are starter bot that serves as the foundation for teams to better understand the basic of FTC robot design, programming, movements, and game strategy. And it's always designed to guide students and mentors as they explore the mechanics and engineering concept behind the competition. So for new teams, especially the starter bot that we're gonna showcase later on, will provide an excellent starting point to learn how the FTC robots are built and how they can be adopted to perform game tasks during the exhibition challenge. So the initiative or this initiative will definitely support our goal of making First Tech Challenge more accessible, more engaging, and more beginner friendly and student entering or who wanted to enter to the program for the first time. Okay, so through hands-on learning and continuous innovation, teams will definitely have the opportunity to improve, to customize, and of course expand your robot design as you prepare for the future FTC competition and activities. So now let's move forward and take a quick look for this decode season, the FTC Game Challenge presented by RTX. Okay. I know that the season is almost done, but we just wanted to have the exhibition game so that we could showcase it to the Philippine community. For this challenge or for this season team challenge, in this challenge, teams will work together to investigate the mystery of the world artifacts through an exciting archaeology inspired robotics game experience. Okay, the game is divided into different phases. So there are autonomous period where robot operate using pre-programmed instruction, and there's tele-op period as well where drivers take control and work strategic to score points. And at the end of the game, where teams complete final object to maximize their score before the match. Okay, but technically, as we move forward, we will be discussing and expound the game. All right, so throughout the game, just to give you an overview, throughout the game, team must classify and score artifacts while working together with alliance partner for them to achieve the highest possible score. But later on, we're gonna showcase some demonstration. And this challenge will definitely encourage a student to combine engineering, coding, and critical thinking and collaborating in fast-paced and exciting competition environment. So, as we go through today's training session, we will further discuss the gameplay, the scoring system, the field elements, and the important mechanic that the teams need to understand for the exhibition. So, giving you that brief introduction of the challenge. It's so what exactly is the first tech challenge? Look at those sample bots from my slide. This FTC is a global robotics program where our student will definitely work together with mentors so that they could design, they could build program and operate robots for an exciting annual game challenge release every season. So as we kick off today, please expect more in the future. It is a hands-on learning experience that will definitely combines all those necessary skills in highly engaging competition environment. So in this first tech challenge, our students are really encouraged not only to create functional robot, but also to think critically. They need to solve real problems, communicate effectively, and collaborate as a team. So for every season, it will definitely present new challenges that pushes team to continuously improve the design, the strategies, and the technical skills. So beyond the competition itself, FTC help out. We will definitely help our student to develop valuable STEM knowledge, valuable leadership skills, valuable confidence and creativity and perseverance. Those are the skills that are very important both inside and outside the classroom. So most importantly, FTC will create opportunities for students to learn by doing, for them to explore future careers in technology and engineering, and for them to become part of a global community of innovators and change makers. So for the 2025 and 2026 season, teams around the world take on the challenge called Decode. Okay, but it's almost done. But as I've mentioned, we just wanted to kick up so that we could share it to the Philippine community. So these season games invite students to explore stories, discovery, and innovation connected to artifacts and human history through an exciting STEM and robotics experience because it's Decode. Okay, so it was inspired by exploration and discovery where teams will work together so that they could design robots that are capable of completing different game objectives while applying creativity, engineering, programming, and strategic thinking. And through this season team, Decode challenged the student to look deeper, to look uh, to think to think critically and for them to collaborate effectively as they gonna solve problem inside the competition field. So through this season, teams will experience hands-on learning while they are developing important skills in robotics. So this year challenge continues the mission of first where we really wanted to inspire young people to become future scientists, future engineers, future innovators, and leaders through engaging and meaningful robotics experiences. Okay, so since we have an overview of First Tech Challenge, let's talk about some of the essential materials and equipment needed to get started in First Tech Challenge. So, what are those things that we need? What are those things that we need to have and able for us to start joining the program? So, to begin building and preparing your robot for the competition, teams will need key components such as the starter bot. So, here in the Philippines, we have this FTC starter kit, the Studica FTC starter kit, and the Rev controller and power bundle. Okay, so we're gonna explore thoroughly those electronic components. But if you wanted to clearly understand what are those things for you to begin, here's the clue or here's the key. So This FTC starter kit will definitely provide the foundational mechanic parts needed for robot construction, for instructional structural components, wheels, hardware, motors, and other essential building materials that the team can use to design, the team that would use to assemble the robot. Okay, as you can see right after the starter kit, meanwhile, you need to have the rev control as well and the power bundle to contains the main electronics and the control system responsible for powering, for programming and operating the robot during the matches. So these tools and components serves as the core foundation of every FTC robots that allows teams to explore engineering, design, programming, and testing and robot operation throughout the season. Okay? Sounds exciting, right? So you do not worry if some of these materials are still new or unfamiliar to you. For later in today's session, our instructor, Sir Jury, and facilitator will definitely discuss the component more thoroughly, including their function, their setup, their usage, and how gonna teams can effectively use them in building their first FTC robot here in the Philippines. Okay, so this training session is designed to help our participating teams, especially the beginners, better understand the fundamentals needed to successfully start their FTC journey here in the Philippines. So technically, this is just the beginning of the online session. There will be 2 more Saturdays that we prepared for everyone so that we could thoroughly discuss essential things to understand. And then when you are decided to embrace the challenge, and if you really wanted to share the exhibition schedule, you just tell us, you just inform us so that we could set up a face-to-face training with you. Okay, then moving forward, before we officially begin our training proper, let us first take a look at the timeline and schedule for the FTC exhibition match program. So the registration is already accomplished, but the timeline for the registration is still ongoing. Okay, giving interested schools and teams the opportunity to sign up and become part of this exciting FTC journey. So you are still welcome to join us. So right after those things, as we begin today, there are series of FTC training and preparation schedule. So this is our kickoff, and then we'll be having 2 Saturdays that will be scheduled next Saturday, May 16, 2026, same time, and then May 23, 2026, that's Saturday as well. So that you are obviously free because it's weekend, okay? But anyways, it's it's live. If you are occupied and there's our prior schedule already, you could actually just repeat the recorded session. So we prepare this training session to guide teams through the essential foundation of First Tech Challenge, including the introduction, the robot hardware, the programming fundamentals, the game strategy and driving, and the mini scrimmage practice session. So if you chooses to join the exhibition game, we'll be setting up practice session, and it should be conducted face to face. Okay, so the goal is, of course, to ensure that all the participating teams, especially the beginners, are equipped with the knowledge, equipped with the skills, equipped with the confidence needed to prepare for the exhibition match. Please take note of that. What's gonna happen on the 25th is an exhibition game. Okay? And finally, the much awaited FTC exhibition match will take place on June 25th, okay, during the fourth day of the Philippine Robotics Olympiad. So this will be an exciting opportunity for teams to showcase your robot, to apply what you have learned throughout the session and experience the FTC competition environment firsthand. Okay? So we are truly excited to begin this journey together and see how teams grow through learning, how teams will grow through collaboration and innovation. And now, to officially start today's training session, it is my honor to introduce the person who will guide us through our FTC learning journey here in the Philippines. Please welcome our instructor in charge for today's training session, Teacher Zuri. Hello, Teacher Jury. Are you ready?
Yes, I'm ready.
All right. So I'll be sharing the spotlight to Sir Jury, and please go ahead.
Okay. Good morning, guys. My name is Juri Triana, and I will be your instructor for today. So let's get started. So in the next hours, we were going to take a thorough, educator-focused look at the first tech challenge, commonly known as the FTC, and specifically at the hardware and structure of the robot our students will be building this season. Before we dive in, I want to frame this session for you. Whether you are a teacher looking to launch an FTC club at your school or a coach who is new to the Studica robotics ecosystem, this presentation is designed to give you a grounding you need, not just to teach this program, but to truly understand it. The tagline for FTC captures the experience perfectly: build, code, and compete. Students don't read about engineering, they live it. They argue about design choices, they make mistakes and iterate, and eventually they put their robot on the competition field and see the results of their work. As educators, our role is to guide that process. And it starts here with the understanding the program itself. Let's get started. So, what is FTC? So, what is exactly is the first tech challenge? At its most fundamental level, FTC is a student robotics program in which teams of young people design, build, program, and test robots to complete a specific set of game tasks. Here's how your cycle works because understanding this rhythm is essential for planning your coaching schedule. Every year, around September, First announces a brand new game challenge at what it is called the kickoff event. This announcement is streamed live, and teams all over the world watch it simultaneously. From the moment the game is revealed, the clock starts. Teams have a number of weeks, typically several months, to design, build, and program their robot before their first qualifying competition. Each season has a unique theme and set of objectives. The game field, the scoring elements, and the game rules all change year to year. This means students cannot just reuse last year's robots. They have to think critically, re-engineer, and adapt. That constant renewal is intentional. It keeps the challenge fresh, and it mirrors the reality of professional engineering, where requirements change and teams must respond. As coaches and teachers, your job during the season cycle is multifaceted. You are mentors guiding students through the engineering design process. You are project manager helping teams stay on schedule. And you are educators connecting the students are doing in the workshop what they are learning in the classroom. And occasionally, you are the mediators helping teammates resolve disagreements about design decisions. The key skills FTC develops in students include mechanical engineering, software programming, project management, communication, and gracious professionalism, which is first term for competing fiercely while treating opponents with respect. These are not just robotic skills, these are life skills. So let's move on to the program overview. FTC does not exist in isolation. It is one program within a broader ecosystem of youth robotics competitions organized by FIRST, which stands for Inspiration and Recognition of Science and Technology. Understanding where FTC fits within this ecosystem helps you position the program correctly to students, parents and school administrators. First, organizes its program by age group, creating what they describe as a pipeline, a journey a student can follow from as young as 4 years old all the way through the high school graduation. Let's walk through each level. At the youngest level, we have First Lego League, which serves children ages 4 to 16 depending on a specific sub-program. Students Lego Mindstorm kits to build small robots and compete on the tabletop game fields. It's approachable, colorful, and wonderful entry point into robotics thinking. From there, students can progress to First Tech Challenge, our focus today, which targets ages 12 to 18 years old. FTC marks a significant leap in complexity. Robots are larger, custom designed, and programmed in Java or blocks using Android-based control system. The game fields are full-sized, and engineering demands are substantial. At the top of the pipeline is First Robotics Competition or FRC, which is open to students ages 14 to 18. FRC robots are typically 100 to 125 pounds, operate on a field the size of a basketball court half, and are built during an intense 6-week build season. Many FRC students have FTC experience, and the transition is smoother as a result. The overarching theme for the current season across the All First program is First Age, a celebration of innovation, discovery, and potential of young people to shape the future. This theme connects all the programs and reminds us that what we do in the classroom and the workshop today has implication of far beyond the competition floor. For your purposes as coaches, teachers, knowing this progression matters for two reasons. First, it gives a roadmap students development. As students who start in FLL at age 10 could be competing in FRC by age 15. Second, it helps you communicate with program's value. To parents and administrators, this is not a one-year activity. It is a multi-year STEM development pathway. Before I describe this year's season in words, I want to let First do it for you. This is the official reveal video for the 25th 2025 to 2026 season, FTC season, the code presented by RTX. As you watch, I want you to pay attention to three things: the game field layout, the game elements, the robots are interacting with, and the types of mechanism you see on the competing robots. We'll unpack all of that right after.
Welcome to the First Tech Challenge 2025-2026 season game, Decode, presented by RTX. Decode is played by 4 randomly selected teams, 2 per alliance. Your opponent for one match may be your partner for another. Robots must be built to meet the specifications in the competition manual and fit within an 18-inch sizing cube. Robots and their extensions must remain within the 18-inch sizing cube until the end game. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. On the playing field is a red alliance goal and a blue alliance goal. At the exit of each goal is the classifier ramp and a gate. April tags are located on the goal to assist with targeting. On the field, there are 24 purple artifacts and 12 green artifacts. Robots start each match in one of 2 locations and can hold up to 3 artifacts. At the start of each match, a motif made up of 3 artifacts is randomly selected and indicated on the obelisk. During the first 30 seconds of the match, robots are autonomous. Robots can use sensors to decode the motif, leave the starting line, and score artifacts in the goal. Artifacts that enter the goal and exit to the classifier ramp earn points. Once the classifier is full, any additional overflow will score, but will earn fewer points. At the end of auto, alliances earn additional points if the artifacts in the classifier match the motif pattern. During the following 2 minutes of the match, drivers control their robots. Robots continue to score in their goal, open the gate to clear the classifier, and collect artifacts from their human player. Alliances that score enough artifacts in their goal throughout the match will earn an additional ranking point.
The last 20 seconds of the teleop period is the endgame.
Robots continue to score to fill their classifier to form the motif pattern. As time runs out, robots race to their base where they can expand in height. Points are awarded to robots partially in their base, and even more points are awarded to robots fully in their base. If both robots fit within their base, the alliance receives bonus points. An alliance that can earn enough points from moving in auto and returning to their base will receive an additional ranking point. The alliance that earns the most points overall wins the match and will earn 3 ranking points. This has been a summary of this season's game, Decode, presented by RTX. For complete rules, please read the competition manual, and always remember to demonstrate the first ethos of gracious professionalism. Good luck, teams, and have a great season.
All right, now that you've seen it, let's talk about what you just watched. Because everything in the video has a direct implication for what we build. The game is called Decode, and at its core, it challenges teams to collect game elements from the field, transport them, and score them into specific targets. Some by placement, some by launching. You may have noticed robots with intake rollers at the front collecting elements off the ground, and shooter mechanisms flinging elements to elevate the targets. This is exactly what the FTC starter bot will be discussing is designed to do. You also likely noticed that the autonomous period at the start of each match. The first 30 seconds where robots act entirely on the pre-programmed instructions with no driver input, and a teleop used controllers for the teleop challenge. So for new teams, even the simple autonomous routine that moves the robot and scores one element is a significant advantage. We'll talk more about that when we reach the actuator sections. Keep this video in mind as we walk through the hardware. Every bracket, every motor, every wheel we discussed today exists to make the actions you just saw possible. The hardware is the how, and the game is the why. Let's move on to the starter bot. Now we arrive at the heart of this presentation, the robot itself. For Decode 2025 to 2026 season, we will be working with the FTC starter bot, a ready-to-build robot design created using a Studica Robotics FTC starter kit. Let me first explain what ready-to-build means in this context, because it has an important implications for how you approach the build process with your students. The starter bot comes with a complete set of parts. Every channel, bracket, motor, servo, screw, and a cable needed to assemble a functioning competition legal robot. It also comes with an official build guide that walks teams through the assembly step by step, with photographs and part callouts. This is not a kit where students simply snap pieces together and plug something in. It is a real engineering assembly challenge. Part must be aligned properly. Shafts must be shimmed correctly. Motors must be wired in the right direction, and servos must be calibrated. Expect your first build to take multiple sessions. That is by design. The starter bot is configured to meet the specific demands of the code. It features four primary mechanisms: an intake system that collects the game elements from the field, a shooting or launching system that propels those elements towards scoring targets, a gate actuations mechanism that controls the flow of the game elements between subsystems, and a basic autonomous routine that allows the robot to act independently during the first 30 seconds of each match. From coaching perspective, the starter bot serves as both an educational tool and a viable competition robot. Novice teams can compete effectively with the starter bot as is. More advanced teams can use it as a baseline and modify or enhance specific subsystems based on their game strategy. The most successful teams are often those who understood the starter bot completely before designing what to change. Before we move on to the what inside the box of the study kit, let me show you the competition guideline. So for the age group, we have 12 to 18 or grade 7 to 12. So team must have one coach and 3 to 4 members, and for the robots or their hardwares, it must be a FTC Studica kit, a rev controller hub, or any laptop or Android phones that you can use for programming. Now let's move on for the robot hardware, and electronics. So let's begin with the electronics, the components that power the control the robot. These are the perhaps the most critical parts of the kit because without working electronics, the robot simply does not function. The primary power source for a robot is a 12-volt 3000 milliamp hour nickel metal hybrid or NIMH battery pack. This is a rechargeable battery that provides electrical energy for all motors, servos, and control electronics on the robot. A fully charged battery is essential for consistent performance in competition, and coaches should establish a charging routine. Batteries should be charged after every practice session and allowed to cool before storage. A kit includes also one NIMH battery pack charger. This is not a fast charger, it charges slowly and safely, which extends the battery lifespan. Teach your students to never leave a battery on the charger unattended for extended periods and never use a damaged battery. Battery safety is serious. It should be part of your team's standard operating procedures. The utility strap secures the battery to the robot's frame. It sounds trivial, but the battery that comes loose during a match can cause a robot shutdown, damage internal components, or create a safety hazard. Always ensure that the battery is properly strapped before any practice run. The on and off power switch. Okay. The on and off switch kit controls the power of the entire robot. FTC rules requires that all robots have an easily accessible power switch, and this kit provides that switch along with the wiring harness needed to install it. Make sure students understand where the power switch is and how to turn the robot off quickly, and this is a safety skill. The smart servo programmer and its companion 6-volt DC battery holder allows coaches and students to configure servo motors independently of the robot's main control system. This is extremely useful for calibrating servo precisions before installation. You can test the servo's range of motion and center point without needing a full robot to be powered and programmed. We will discuss servos in more detail when we reach the actuator section. Moving on to cable management components, these might seem unglamorous, but experienced teams know that well-wired robot is reliable robot. Cable failures are among the most common causes of robot malfunctions at competitions, and almost all of them are preventable. The XT30 female to P45 cable connects to the battery pack of the robot's rev control hub via a power pole connector. This is the main power feed. This is the main power feed. Everything downstream depends on this cable being secured and undamaged. Inspect it before every practice. The power pole to JST-VH cables, four of them connect from the control hub motor ports to each of the four drive motors. The expansion encoder cables, also four, carry encoder data back from the motors to the hub, allowing the software to track each motor's rotation count precisely. Accurate encoder data is what makes autonomous routines possible. The rubber grommets protect cables where they pass through holes in the robot's metal frame. Without grommets, metal edges can cut through cables insulation over time, eventually causing short circuits. Always use the grommets whenever cables pass through structural holes. The 100 pull zip ties are cable management tools. Use them generously to bundle and route cables away from the moving parts. A cable caught in the gear of or wheel can disable the robots instantly. A polycarbonate perforated sheets served as the mounting panels for electronics components, the control hub, sensors, and other devices attached to these panels, which are then secured to a robot's frame. The perforation allows for flexible positions and easy attachments. Servo extension cables are and the server Y-split cable extends servo signal wires to reach servos mounted farther from the control hub. And the Y-split allows one signal port to control two servos simultaneously, useful for mechanisms that require synchronized servo movement. Every kit includes a set of tools, and understanding the purpose of each one helps coaches ensure students are using the right tool for the right job, which reduce stripped screws, damaged parts, and frustration. The black robot toolbox keeps all the tools organized in one place. Encourage students to always return tools to the box after use. A missing hex key at the wrong moment during a build session wastes time and creates stress. The 2.5 millimeter hex ball and screwdriver is one of the frequently used tool in the kit. The 2.5 size matches the socket of M3 screws which are used throughout the robot. The ball end allows the driver to engage the screw and at an angle, which is invaluable when working in tight spaces where the straight driver cannot reach. The 7-piece hex key metric covers sizes from 1.5 millimeters to 6 millimeters, giving students access to full range of fastener sizes used in Studica hardware. The 5.5 the 5.5 combination wrench and 5.5 nut driver are used for M3 cap nuts, which secure many of the robot's structural connections. The 8 millimeter wrench handles larger fasteners found on the motor mounts and the shaft hardware, teaching students use the wrench properly. Applying torque without over-tightening, it's an important mechanical skills. Perhaps the most important consumable in the tool section is the tight thread locker. This is the low strength thread locking compound applying to screws in high vibration areas of the robot, particularly drivetrain components and shooter mechanisms. Without the thread locker, screws will gradually back out during operation, leading to structural failures that are difficult to diagnose mid-competition. Teach students to apply a small drop, not a large amount. Less is more with thread locker. Let's move on to the hardware channels. The physical skeleton of a robot. The primary structural element in the Studica system is the U-channel, an aluminum extrusion with a U-shaped cross-section perforated with holes at the regular intervals for fastener attachment. U-channels come in multiple lengths: 336 millimeters, 288 millimeters, and 192 millimeters, 96 millimeters, and 48 millimeters. Longer channels form the main frame members. The chassis rails, the elevator structure, the arm assemblies. Shorter channels serve as connectors, gussets, and end caps. Understanding which length to use where is part of the engineering design process. In addition to U-channels, the kit includes low-profile U-channels in 432 mm and 192 lengths. Low-profile channels are shallower than standard channels, allowing them to fit in space-constrained areas of the robot where standard channel would be too tall. They are commonly used for electronics mounting platform as the secondary frame members. A key teaching point about channels: the holes are not random. They follow a consistent pattern that allows components to be attached at precise, repeatable positions and repeatable precisions. This means students can plan their build on paper or in a CAD program, and then transfer those dimensions directly to the physical robot with confidence. Encouraging students sketch their designs before building is one of the most effective habits you can teach. Now let's move on to beams. Complementing the U-channels are the structural beams. Two types. You have two types: L-beams and square beams. L-beams, available in 48 mm and 96 mm lengths, have an L-shaped cross-section that makes them ideal for creating perpendicular connections between channel members. They add rigidly at corners and joints where two channels meet at the 90 degrees. Square beams in 48 mm, 144 mm, and 288 mm sizes have a square cross-section and are used for internal frame bracing. Where U-channels from the outer structure of the square beams often add an internal stiffness that prevents the frame from flexing or racking under load. A robot that flexes during operation will have an inconsistent mechanism performance. A stiff, well-braced frame is a foundation of a reliable robot. From an educational standpoint, beams and channels together give student hands-on experience with structural engineering concepts. Load paths, triangulation, moment arms, in a tangible, immediate way. When a student notices that adding a beam makes the robot noticeably stiffer, they understand structural engineering in a way that no textbook diagram can fully convey. Now for the brackets. Brackets are the connectors that join structural members together. The Studica system includes a rich variety of brackets type, each serving a specific geometric purpose. A flat brackets in sizes ranging from 96 mm to 288 mm are used to connect two structural members in the same plane. Imagine joining two channels end to end or reinforcing a long span with a parallel plate. The 90-degree bracket creates right angle right angle connections between channels oriented perpendicular to each other. The T-bracket creates a three-way joint, useful wherever a cross member a mainframe meets a mainframe rail. Inside U brackets fit inside the channel cavity and allows attachment without adding external bulk, useful in a tight-fitting assemblies. L brackets and inside L brackets serving similar functions but different orientations, giving students flexibility in how they approach corner connections. Battery clips are purposely built brackets designed to hold the battery packs securely within the robot frame. For new coaches, a common mistake to underestimate the importance of a bracket selection. Students sometimes reach for whatever bracket is nearest rather than the one that is geometrically correct. This leads to misaligned components, extra stress on fasteners, and robots that don't perform as designed. Taking the time to discuss bracket selection with the students before the build begins saves significantly rework time later. It is also worth noting that the brackets in this kit are made from the anodized aluminum. They are lightweight but strong. However, they are not indestructible. Brackets that are over-torqued, improperly loaded, or repeatedly removed and reinstalled will eventually fatigue. Teaching students to handle hardware with care is the part of engineering culture you are cultivating. Mounting plates. Mounting plates are specialized structural components designed to hold a specific hardware, primarily motors and servos, in precise, secure precisions. Getting motor and servo mounting right is one of the most important mechanical tasks in the build because the motors that shift position during operation will misalign gears, miss tension belts, and introduce mechanical failures. The motor clamp kit uses a cylindrical clamp to hold the body of a Maverick DC motor. The Clover mount plate is an alternative mount that bolts directly to the motor's faceplate. It provide faceplate. Provides a more rigid, lower profile attachment. End piece plates cap the ends of channels where motors are installed, providing additional structural support to the motor mount assembly. For servos, the kit includes servo standard front mounts and servo mount flat plates. These components allow the servos to to be positioned precisely in any orientation needed by the mechanical design. Proper servo mounting matters, especially for the gate and intake mechanisms in the starter pod, where precise servo positioning directly affects the robot's scoring capability. As coach, pay particular attention to the motor mount alignment during the build. Take the time to measure and verify that motors are parallel to their respective shafts and that there are no lateral stress on the shaft couplings. 10 minutes of alignment work during the build prevents hours of troubleshooting at competition. Now let's move on to the hex shafts. Hex shafts are rotating axles that transmit mechanical power throughout the robot. The Studicast system uses 6 mm hex shafts, axles with a hexagonal cross-section rather than a circular one. Hex shape is a key feature. It prevents slipping between the shaft and whatever it is mounted on it, unlike a round shaft which rely on a friction or a set screws. The kit includes shafts in 5 lengths: 35 mm, 70 mm, 96 mm, 140 mm, and 32 mm. Selecting the correct shaft length for each application is a mechanical engineering decision. Too short and there is not enough bearing support, the shaft will flex under load. Too long, and the shaft extend unnecessarily, adding weight and create collision risks. The 35 and 70 mm shafts are typically used for short axle runs, small gear connections, idler pulleys, and tight mechanism joints. The 96 mm and 140 mm shafts serve as a wheel axles and primary mechanism drives. The 432 shaft is notable for its length. It spans wide assemblies such as full width of an intake roller, passing through multiple bearings and gears along its length. An important concept for students to understand is that a hex shaft must be supported at the both ends, bearing whenever possible. An unsupported shaft end creates a cantilevered load condition. The shaft bends under force, accelerating wear on the bearings and hubs. In your build sessions, always ask students where their shaft bearings are located before finalizing any shaft-based assembly. Now let's move on for the motors and actuators. Actuators are components that create motion, the muscles of the robot. The starter kit includes two types of actuators, DC motors and servo motors. The DC motors in this kit are the Maverick motors from Studica, equipped with planetary gearboxes. Planetary gearboxes are used because they are compact, efficient, and offer a wide range of gear ratios. The kit includes two gear ratio options. The 3.7 to 1 ratio delivers a high rotational speed with moderate torque, ideal for shooter wheels which need to spin fast to launch game elements. The 50.9 to 1 ratio delivers a high torque at lower speed, ideal for the drive wheels, where pushing power and reliable acceleration matter more than raw speed. Teaching students the relationship between gear ratio, torque, and speed is one of the most valuable concepts FTC offers. The basic principle: increasing gear reduction multiplies torque but divides speed proportionally. A 50.9 to 1 gearbox on a motor spinning at 6,000 RPM produces an output of approximately 1.18 118 RPM, much slower. But with 50.9 times the turning force, students who understand this can make intelligent decisions about mechanism design. The servo motors in the kit are multi-mode smart servos, two of the Model 200 and two of the standard model. What makes this servo unique is their programmability. Using the Smart Robot Servo Programmer we discussed earlier, these servos can be configured in multiple modes. Standard servo mode with a 270-degree range, continuous rotation mode for spinning mechanisms, or extend range mode. The flexibility means one servo model can serve many different functions on the robot, reducing the number of unique components terms need to stock and understand. From an educational perspective, servos and motors together give students hands-on experience with electromechanical systems where electrical signals are converted into precise mechanical motion. This is a foundational concept in robotics, automation, and many engineering disciplines. Now for the stand-ups and spacers. Stand-ups and spacers are the positioning components of the robot. They control the distance and alignment between structural and mechanical elements. Small details that have a significant impact on the performance. Standoffs in 25 millimeters, 52 millimeters, and male to female configurations create fixed separations between structural layers. The electronics mounting panel, for example, is typically elevated above the main glass frames using standoffs, creating clearance for wiring and components underneath. Male to female standoffs allow stacking, combining two standoffs to achieve a custom height. Screw spacers in 1 millimeter and 2 millimeters thickness are used Let's skip this part for the connectors, this the hub. Let's move on to the main controller hub. So the main component or the control chain or the main brain for the FTC study kit is the rev. Now let's talk about the control system, the brain of the robot. This is how your students will communicate with the robot, send commands, and receive feedbacks during a match. In FTC, teams have option to use Android smartphones as a part of the control setup, specifically a smartphone that can serve as a driver station or the robot controller, or in some configurations both. Let's break those two roles down because understanding the distinction of important of coaches and the students. The driver station is a device your drivers hold during a match. Think of it as a command centers and the driver's hands. It runs in the FTC driver station app, connects to the game controllers or gamepads, and it sends commands wirelessly to the robot over Wi-Fi Direct. For a smartphones to function as a driver station, it needs the FTC driver station. It needs the FTC driver station app installed, and it will require an OTG or on-the-go USB adapter along with the USB hub to physically connect the gamepads without the OTG adapter. The phone cannot recognize the gamepad controllers. The robot controller, on the other hand, lives on the robot itself. It receives command from the driver station, executes the programmed logic, and sends signals to the rev control hub. You can also connect your mobile phone or the driver station, FTC driver station, using a Wi-Fi that is included in the rev control hub. So the rev control hub, when which then talks to motors, servos, and sensors. You can see the rev control hub here on the slide, the orange and the black. Black is what is physically interfaced on the old robot's hardware. For the new teams, the most important thing to understand is this. The smartphone and the control hub work together as a system. The phone handles the high-level logic and the communication. The control hub handles the low-level hardware connections. Neither one alone is sufficient. You need both. As coaches, make sure your team keeps both devices charged before every practice and competition. A dead driver station phone means no robot control. A dead control hub means no motors or servos. Build charging into your team's pre-practice checklist from the day one. To sum up, and with that, we have completed our comprehensive walkthrough to the First Tech Challenge program and full hardware inventory of the FTC Starter Kit for a Decode 2025-2026 season. I want you to leave a few key takeaways as a coach and educators. First, knowledge of the hardware is the foundation of the effective coaching. You cannot guide students through the build if you do not know what each part is and why it is there. Review this material, handle the parts, and ask questions. That is exactly what your students will be doing. Second, FTC teaches much more than robotics. It teaches students how to work under deadlines, how to resolve disagreements constructively, how to test and iterate when something doesn't work, and how to communicate with their ideas clearly. Your role as coach is to facilitate that learning process is not just to build a winning robot. Third, document everything. The engineering portfolio is not an afterthought. It is a record of learning and it is judged alongside the robot at the competition. Help your students develop the habit of writing down their decisions, their tests, and their reflections from their very first day. The students you coach in FTC will carry the skills, the mindset, and the memories of this experience far into their future. That is the real mission. Thank you for your time today, and I will look seeing your teams in the competition field. So join us again in the new amazing lesson on May 16. Here are the keynotes for the next session: FTC programming basics, teleop control, autonomous mode, control systems, components configuration, and basic robotics movement. Thank you, everyone.
First Tech Challenge challenges kids ages 12 to 18 to program, design, build, and compete with robots.
First Tech Challenge is one of 3 engaging FIRST programs.
Every year they release a new challenge.
Once you get the challenge, you figure out your game plan.
In a variety of coding languages.
Every year you learn more and more about coding, so then your code's gonna get better and better.
Personally, I do not learn hearing about it, but hands-on is just go into it. Instead of saying, oh, I know how to build this robot, I can say, I built this robot.
In First Tech Challenge, students are developing a broad range of skills.
Manufacturing, hardware, troubleshooting, but there's also a lot of things that you learn that you wouldn't necessarily think about. People skills.
Problem-solving skills, helping one another, helping other teams.
The program draws so many students that come in who just want to do the marketing, who just want to do fundraising. And that's a great thing that the kids learn very early on.
The model of FIRST has provided incredible opportunities for the students to interact with professionals.
Whenever I ask my mentors a question, they always flip the question around and ask, where would you find the answer to that question if I weren't here? They slowly built my confidence up so much more to a point where we weren't asking them questions, we were just going.
Each team has to compete at a local event, win awards at the local event, and then they're able to move on to the first championship.
You walk into the room and there's that smell. The smell of robots.
There's different languages, different culture. It's just the best thing ever.
There are scholarships for colleges, universities, as well.
Okay, so I would like to invite you to join the next session in May 16. So the topic is block coding and robot control. The key topic is FTC programming basics, tele-op control, which uses the controller or the gamepad, autonomous mode, which is automatic running, control systems for the rev controls, how they work, components configuration, and the basic robot movements. So join our live sessions in May 16. Thank you.
It's ages 12 to 18 to program, design, build, and compete with robots.
First Tech Challenge is one of 3 engaging FIRST programs.
Every year they release a new challenge.
Once you get the challenge, you figure out your game plan.
Teams use a reusable kit to program robots in a variety of coding languages.
Every year you also learn more and more about coding, so then your code's gonna get better and better.
Personally, I do not learn hearing about it, but hands-on is just go into it. Instead of saying, oh, I know how to build this robot, I can say, I built this robot.
In First Tech Challenge, students are developing a broad range of skills.
Manufacturing, hardware, troubleshooting, but there's also a lot of things that you learn that you wouldn't necessarily think about. People skills.
Problem-solving skills, helping one another, helping other teams.
The program draws so many students that come in who just want to do the marketing, who just want to do fundraising. And that's a great thing that the kids learn very early on.
The model of FIRST has provided incredible opportunities for the students to interact with professionals.
Whenever I asked my mentors the question, they always flipped the question around and asked, where would you find the answer to that question if I weren't here? They slowly built my confidence up so much more to a point where we weren't asking them questions, we were just going.
Each team has to compete at a local event, win awards at the local event, and then they're able to move on to the first championship.
You walk into the room and there's that smell, the smell of robots.
There's different languages, different culture. It's just the best thing ever.
There are scholarships for colleges, universities, as well as technical programs.
I think it's incredibly important for youth to see careers in science and engineering as a possibility for them.
First Tech Challenge is like a avenue for me to express my creativity with like-minded individuals that later become my friends through the program.
First in one word, wow.
And
First is inspiration.
first is amazing.
First is hope.